Welcome to the Explainer. Today, we're going to completely transform how you look at large language models right from the ground up. If you're a Python developer, you are in exactly the right place because we are unpacking a phenomenal resource. It's a book literally titled From Math to GPT, Building LLMs from Scratch. So, let's quickly run through our roadmap for today. We'll hit Section 1, the LLM black box. Section 2, bridging math and code. Section 3, the six-stage learning process. Section 4, hands-on Colab notebooks. Section 5, building a nano GPT. And finally, Section 6, start building from scratch. This is a highly structured path designed to take you from basic Python and college math all the way to building a working nano GPT.
All right, kicking things off with Section 1, the LLM black box. We're starting with a problem that almost every software engineer faces today.
Seriously, think about it for a second. We all use ChatGPT, right? We make API calls constantly. It is so incredibly easy to just pass a prompt string to an endpoint and get this magical text completion back. But peeking inside that black box? Yeah, it can feel totally intimidating, especially if your college-level linear algebra is a bit rusty. You might know exactly how to integrate a model into a web app, but do you know how a massive matrix multiplication dynamically processes your specific query? Or how an attention mechanism calculates weights to decide which words in your prompt actually matter most? Well, if not, you're missing out on a massive, empowering layer of understanding.
Moving on to Section 2, bridging math and code. Because here is the real secret to conquering that intimidating monster of advanced mathematics. That quote right there brilliantly illustrates our core philosophy today. By understanding the math, you move beyond just blindly using models to actually understanding and building them directly. Like, why does a softmax function create a probability distribution that allows the model to pick the next word? How is backpropagation literally the backbone of training AI? Just a mechanical, step-by-step application of the chain rule you probably learned back in college? When you take the time to map these abstract concepts to hard code, the magic entirely disappears and the actual beautiful engineering emerges.
And these concepts definitely don't just appear out of thin air. We're talking about an evolution. The journey starts way back with Rosenblatt's 1957 perceptron, the absolute simplest form of an artificial neuron. From there, it walks you through the 2014 Bahdanau attention mechanism and then highlights the massive breakthrough, the 2017 transformer architecture. This is a game changer because before transformers, models process text sequentially, one word at a time, creating huge bottlenecks. Transformers changed everything by looking at everything at once, allowing for massive parallel processing. That paradigm shift leads us right into the foundation of modern large language models like GPT-2 and GPT-3.
Section 3, the six-stage learning process. So, how exactly does this book systematically rebuild your foundational knowledge without completely overwhelming you?
The crucial point here is this rigorous six-stage learning process. This isn't just passively reading dense academic theory. For every single core concept, you start with a clear definition, followed by intuition, so you actually grasp the why. Then you get the equation derivation, step by step. But you don't stop at the chalkboard. That abstract equation instantly becomes tangible through code implementation in Python. Finally, you run a benchmark to see its real-world performance, and you see its application inside a real LLM. It is this perfect closed-loop system that just clicks for a developer's brain. Now, let's talk about the hardware reality, which is explicitly called out. Say, a matrix multiplication of size 1024 takes 8 milliseconds on your machine. If you do the exact same math for a matrix size of 4096, it scales up cubically. It suddenly takes 512 milliseconds. When you realize an LLM performs this calculation thousands of times across hundreds of massive layers in just a single forward pass, measuring these timing benchmarks proves exactly why GPUs aren't just a luxury, they are practically essential for modern AI. You get to experience that hardware bottleneck firsthand.
Section 4. Hands-on Colab notebooks. To truly learn this stuff and retain it, you have to get your hands dirty.
We all know developers love clear documentation and immediate hands-on practice. There are exactly 33 chapters, and every single one has a corresponding, ready-to-run Colab notebook. You can seamlessly toggle between CPU and GPU environments to run those performance benchmarks we just talked about. It also uses a custom LLM math utility package to abstract away the boilerplate and keep the core code incredibly clean. Plus, built-in practice problems with solutions. You can explore this entire official GitHub repository right now by heading over to bit.ly/4f1ys. And this mapping perfectly demonstrates the fundamental promise. If you know Python, every theoretical math concept maps directly to a line of code you can actually run. Take entropy or KL divergence. That math notation can look like a totally foreign language, but right next to it is the clean Python implementation. By writing out entropy of P or calculating cross-entropy loss, the math immediately becomes executable logic. KL divergence, for instance, is just a mathematical way to measure how one probability distribution differs from another, which is absolutely crucial for evaluating how well a model predicts the next word. It bridges the gap beautifully.
Section 5. Building and Nano GPT. All of these foundational chapters act as individual quests leading you to the ultimate goal.
You aren't just recreating legacy code here. You will literally put all the modern pieces together yourself. You're assembling advanced architectural components used in state-of-the-art models right now. Components like rope, rotary position embeddings, which cleverly injects positional information so the model understands word order. We're talking grouped query attention to save memory, RMS norm, and Swiglu feed-forward networks. You code these up piece by piece and then combine them into a complete working training loop. And honestly, it doesn't shy away from real, frustrating engineering quirks either. There is a specific warning regarding PyTorch tensors, highlighting that the view function is only safe when a tensor is stored contiguously in memory. If you've been transposing axes, you have to intentionally use reshape or explicitly call contiguous first. These are the practical, in-the-weeds debugging tips that ensure your AI project doesn't just work in theory, but actually executes in practice on your hardware.
Finally, Section 6. Start building from scratch. The ultimate question is how you step out of the dark and embark on this engineering journey yourself.
It's time to empower yourself as a developer. You can go from relying entirely on abstract API endpoints to actually understanding the deep tensors, the model weights, and the foundational math powering this whole AI revolution. You can grab From Math to GPT, Building LLMs from Scratch on Amazon right now using the direct link amazon.com/dp/b0h-h2p9w3.
I'm going to leave you with that provocative thought. Are you ready to stop just using large language models and actually start building them? It is profoundly rewarding to demystify these massive models and realize they are ultimately just elegant, powerful combinations of math and code that you can master. Thanks for joining this explainer, and happy building.